Hello everyone, I'm Mr. Jason Garcia, your chemistry teacher for today. For today's lesson, we will talk about a very interesting topic in chemistry. Before that, make sure that you have a copy of your module and a pen, of course, for you to write down keywords that may seem new and difficult to understand. You can also watch with your other family members for an easier and effective discussion. Are you ready? Let's start. For this lesson, our most essential competency is to define mole and calculate the number of moles in given compounds with the code S9MT-Q2-W6-T2. To start off, what is a mole? A mole also can be expressed as mole spelled as MOL in chemistry, a standard scientific unit for measuring large quantities of very small entities, such as atoms, molecules, or other specified particles. The mole designate an extreme large number of units, and that is 6.02 to 14076 times 10 raised to the 23rd power to be exact, or can be expressed as 6.02 times 10 raised to the 23rd power. The mole was previously defined as the number of atoms determined experimentally to be found in 12 grams of carbon-12. The number of units in a mole also bear the name Avogadro's number or Avogadro's constant in honor of the Italian physicist Amadeo Avogadro. Avogadro proposed that equal volume of gases under the same condition contain the same amount of molecules, a hypothesis that proved useful in determining atomic and molecular weight, which led to the concept of the mole. Just to remind you, dear chemistry students, you will be needing to use a periodic table of elements to answer the succeeding activities. And here, it's being showcased that 1 mole of carbon is equal to 12 grams. Remember, the number of atoms or other particles in a mole is the same for all substances. The mole is related to the mass of an element in the following way. Let me explain the one I've shown to you earlier. 1 mole of carbon-12 has 6.022 14076 times 10 raised to the 23rd power of atoms and a mass of 12 grams. In comparison, 1 mole of oxygen has the same number of atoms and has a mass of 15.99 grams. Oxygen, therefore, has a greater mass than carbon. This reasoning can also be applied to molecular or formula weights. Now, before we proceed to our activity proper, let's have some review exercises. For our activity number 1, using a periodic table, determine the atomic mass of the following elements. Number 1, 1 mole of silver. Number 2, 1 mole of neon. Kindly use your periodic table to answer. Let me now reveal the answers for our practice exercise number 1. 1 mole of silver is equal to 107.89 grams or 107.89 AMU. AMU means atomic mass unit. Number 2, 1 mole of neon is equal to 20.18 grams or 20.18 AMU. Did you get the same answer? Now, let's have our review exercise number 2. Using a periodic table, determine the molar mass of the following compounds. Number 1, 3 moles of water. Number 2, 1 mole of table salt. Let's see whether you get the same answer. Okay, for number 1, 3 moles of water is equal to 18.02 grams. That is per mole. So since the given is 3 moles, we need to multiply it by 3. So 3 moles of water is equal to 54.06 grams. In number 2, 1 mole of table salt is equal to 48 grams. Did you get the same answer? I think now you are ready for our conversion. We'll be discussing two conversions. One is mole to mass and then mass to mole. Shall we begin? Let's have the sample problem for mole to mass conversion. What is the mass of 3.987 mole of aluminum? To calculate for the unknown quantity in this problem is to determine the atomic mass of aluminum. 1 mole of aluminum is equal to 26.98 grams. Let's multiply the given number of mole to the atomic or molecular mass of the substance. So the given is 3.987 mole of aluminum multiplied by 26.98 grams divided by 1 mole is equal to 107.6 grams of aluminum. So it means that 3.987 mole of aluminum is equal to 107.6 grams. Now let's proceed to mass to mole conversion. How many moles are present in 100 grams of water? Initially, what do we do in order to solve for this problem? First, determine the molar mass of water. 2 moles of hydrogen is equal to 2.02 grams and 1 mole of oxygen is equal to 16 grams. Therefore, 1 mole of water having the chemical formula of H2O has a mass of 18.02 grams. Then, divide the given mass to the atomic or molecular mass of the substance. 108 grams is the given mass divided by 18.02 grams is equal to 5.99 mole. The answer for this problem is 108 grams of water is equal to 5.99 moles. Did you get the same answer? Let me help you summarize the lesson for today. Mole is an SI unit to express the amount of a substance. Molar mass is the mass of 1 mole of a substance. Also, in mole to mass or mass to mole conversions, determine first the atomic mass or molecular mass of the given substance. Then you may convert the given value to the unknown value using dimensional analysis or factor method. And that ends our lesson for today. Did you understand the presentation? If not, you may go back to the lesson presented to you. If today's lesson is clear enough for you, you may now answer the exercises in your module. Good luck!